here in this video, we're going to look at example 5 from section 3.3, and we're checking whether x minus a is a factor of p of x. So we're using kind of a combination of remainder theorem and factor theorem, but really what we're looking to do is we're using synthetic division, and we want to see if there's a remainder or not. So if there is a remainder, so if the remainder equals 0, then we would say yes, it is a factor. So that means it goes into it, we'll say evenly. All right, you can divide by that specific term. If the remainder is anything else, so it doesn't matter what number it is, anything but 0, so if the remainder does not equal 0, then you would say no, it is not a factor. So we're using synthetic division, and we're just going to interpret the remainder to tell us whether it is or is not a factor. So part A, looking at all my terms, I have fourth power, third, second, first, and my x to the 0. So everything is there. I don't need any placeholders, so that is good to know. And we're going to take all of our leading coefficients. All right, so let's write 1, -8, 16, -23, and -6. So remember, all of those come from there. And then we're going to use our divisor. So this -6 would go here, but be careful. Since they're giving us the x minus 6 term, we do need to change the sign because our a value, remember you're subtracting, it's x minus a is positive 6. So let's do synthetic division. Drop down our 1. And this time I'm not going to show all of my arrows, but remember to get from here to here, you're multiplying by this term. All right, that multiplying by 6. So I'll just write it once as a reminder. 1 times 6 would be 6, and then we're just going to keep adding. So -8 plus 6 would be -2. We're going to multiply by 6 again, so this would be -12. 16 plus -12 would be a positive 4. 4 times 6 is 24. -23 plus 24 will be a positive 1. 1 times 6 is a positive 6. And then -6 plus 6 is 0. All right, I said I wasn't going to, but I'm going to put my arrows back in here so we can remind ourselves what we did. So these are all times 6. All right, so in this case, our remainder is 0. So what does that tell me? The question really is we're asking, is x minus 6 a factor? All right, that's what they want to know. Since our remainder is 0, that tells me that yes, x minus 6 is a factor. All right, and that's my answer. I could just kind of say yes. Straightforward. I don't think you'll really have any issues. Should probably be pretty good at synthetic division by now, but you get the idea. So now in part B, we're going to do the same thing. Not too much is going to change, but it's nice to see another example. Now for this problem, my degrees, I have the fifth power, the third power, second, first, and I have my constant. So that would be a 1. I'm missing the fourth power. All right, that's absent. So I need that placeholder. Okay, so this is a good example of what we need to do. So let's take our leading terms. That first one would be a 1. The x to the fourth is missing, so we need a 0 placeholder. And then we have -5, 9, -1, and 3. And then our divisor comes from here. But remember, we're dealing with x minus a. So this is, for x minus a, this is really x minus -3. So we need to change the sign. So that's going to be a -3. And the question they're asking, again, like I mentioned above, is they want to know, is x plus 3 a factor? So we're going to use synthetic division to determine that. Drop down the 1. and then 1 times negative 3, and we need to fill out our chart, or our 2 rows. I keep saying chart, but you get the idea. Add them up. It's a terrible 3. Multiply, negative 3 and negative 9 would be, sorry, negative 3 and negative 3 would be positive 9. That would give us 4. 4 times negative 3 is negative 12. Always check your work as you go along. Just be careful, don't rush through these. 9 and negative 12 would be negative 3. Again, negative 3 times negative 3 would be 9. Negative 1 and 9 would give us 8. 8 and negative 3 is negative 24. Add those up, and we get negative 21. That is our remainder. Now, the remainder clearly is not 0, so that means there is a remainder, which means the answer to our question, is x plus 3 a factor? The answer is no. X plus 3 is not a factor. Right? It doesn't matter how small or big the remainder is. If the remainder is not 0, it's not a factor. Okay, it has to be 0 to be a factor, which is what happened in example A. But in example B, clearly we had a remainder, so then that binomial x plus 3 is not a factor. Right, that's pretty much it for this section. Hopefully by now you have a pretty good handle on what synthetic division looks like and the process. This example, obviously we didn't write out the whole answer. We're just trying to answer the question, but you'll see that you still need to use the synthetic division process to determine if something is a factor.